So this video is for integrated 2. This is the chapter 2, D-Day 2. And a couple different ways you can do this problem here for number 1. I'm going to think of this as an exterior angle. And I'm going to think of these two angles as the two remote interior angles. And I know that the exterior angle is equal to the sum of the two remote interior angles. So I'm going to add the 4x and the x plus 20 and solve. And when I do that, I get 120 is equal to 5x plus 20. I get 100 is equal to 5x. So x is equal to 20. And then my justification is the exterior angle theorem. On number 2, in 1999, there were 285 cell phones in 1999. In the small town of Centerville, the number of subscribers increased by 75% per year after 1999. How many cell phone subscribers were there in 2019? So if something's increasing by 75%, that means my multiplier is going to be 100% plus 75% or 175. That makes it 1.75. So then I'm going to have 285, which is our initial value, times 1.75 raised to the power x. Now, the difference between the year 2019 and 1999 is 20 years. So I am going to raise this to the 20th power. So we're going to have 285 times 1.75 to the 20th. And when I put that in my calculator, I get 20682633.38. So 20,682,633.38. On number 3, we're going to be proving, we're going to do a flowchart proof, whether these are congruent. So first thing I notice is that AB is going to be congruent to AC, so we know that. I also know that this BD is going to be in both triangles. And then they gave us that this angle here is going to be the same as this angle here. So for this, I'm going to say, yes, they are congruent. And I'm going to give the pieces. So I'm going to say, let me do it down here, that line segment AB is congruent to line segment BC, given. I'm going to say angle, and I cannot call that angle B, I'm going to call it angle ABD is congruent to angle CBD, given. And then I'm going to say line segment BD is congruent to line segment BD, and that's reflexive property. And then from here, I can say that this and this and this are going to lead to these two triangles being congruent. So I'm going to call the first one triangle ABD, for example. And I'm going to say that's going to be congruent to CBD. And I'm going to give the reason side angle side congruence. Okay. Now on the next problem, this is going to be where we're dealing with part side splitter and part just with similar triangles and part just similar triangles. So when I'm talking about side splitter, the sides I cannot use the side splitter for. I cannot do it with that A. I cannot do it with C. I cannot do it with D. Cannot, well, also this 12.5, but any of those are not split sides. Okay, the other two sides, this whole side and all those pieces, one I did in green, and this whole side and all of the pieces, I can use the side splitter for those. So I'm going to be setting up some ratios that I'm going to do the side splitter for. So I am going to say, if I'm dealing with these, I'm be looking at the 15, the 10, the 12, and the F. And I'm going to set up a ratio, and I'm going to say F is to 12 as 10 is to 15, and I'm going to cross multiply and solve. And when I do, I get an 8. So now I know that that is 8. Then let's say I try to find E. Okay, so now for E, I am going to look at, I'm going to use the 12 and the 15 compared to the E and the 5. So I'm going to set up her proportion. I'm going to say E is to 5 as 12 is to 15. And I'm going to cross multiply and solve, and I'm going to end up getting 15E is equal to 60. So E is equal to 4. So this is going to be a 4. I'm going to do a similar idea to find B. I am going to use the 15 and the 12 again with the 12.5 in the B. So these ones I'm all doing side splitter. Let me just, okay, so that's what I'm doing there. Okay, so let me do one for B. So I'm going to say B is to 15 as 12.5 is to 12. So I get 12B is equal to 15 times 12.5. I get 187.5. And when I divide by 12, I get 15.625. So this right here is 15.625. So now when I'm trying to find all of the red pieces, none of those can I use the side splitter pieces. So what I'm going to do is I'm going to use this small triangle here each time. Okay, that triangle here. So let me just kind of redraw it out. So I'm going to be doing this one here. Where this is D, and this is 8, and this is 10 from the orange triangle. And then I'm going to compare it to this triangle here that I'm going to do in, let's say, teal. So this one here, which is going to include that piece. And so when I'm looking at that triangle, I am going to be looking at my 15 and my 10, which is 25. My 12 and my 8, which is going to add to a 20. So if I was to draw that triangle out, this is 12.5, this is 20, and this is 25. So if I was to do a ratio here, I could say D is to 12.5, okay, where I'm doing the whole bases, and I have to do to the whole side. So I think I'm going to do it with the D is with 10 and the 25. Then I'm going to cross multiply, get 25D is equal to 125. So D is going to be 5. So this here is 5. And then I can do the same idea to find C. So I am going to be using this time the 5, the 15, and the 10, which I'm going to add up all the way together. And so that triangle is going to be C. 5 and 15 is 20 plus 10, that's going to be 30. I'm talking about all the way here is going to be 30. And I'm going to be comparing that to this smaller triangle. Okay. Or actually, I'm going to do it to the one I just did, this one here, because I know all those pieces. So for this one, I'm going to say C is to 12.5 as 30 is to, sorry, C is to 12.5 as 30 is to 25. And then I'm going to cross multiply and work that out. So I'm going to get 25C is equal to 30 times 12.5 is a 375. Divided by 25 is a 15. So I get that my C is 15. And then I'm going to use that same triangle, the one, I'll do it in teal. Okay, I'm using this one up here each time. And I'm going to do it with, to find the A this time. So now I'm going to try to find A. So for that triangle, I have that this is A. This side here is, I think I'm going to use the other side this time. 12.5, 4, 12, 8. So that's 20, 24. That's going to be a 36.5. So I think I'm going to use that. And when I'm saying that, I'm going to be using this and this with this and this. And I'm going to set that up. So I'm going to do A is to 12.5 as 36.5 is to 20. I get 20A is equal to 12.5 times 36.5, 456.25. So A is going to be equal to 22.8125. So 22.8125. On number 5, I'm going to make this into a rectangle. So I'm going to do that. And when I do that, this is going to become a 9 plus 18 across the bottom, which is going to be a 27. And then this whole entire thing is going to be a 20 plus a 9, which is 29. And then I'm going to work it out from there. So the rectangle is going to be have an area of 29 times 27. And that's going to be a 29 times 27. 783 for that whole pink rectangle. Don't have all of it. This piece right here is 9 times 18. And that's a 162. So I'm going to be minusing 162 from this. And then this trapezoid. I have the base of 16 here. This other base is going to be a 27. I have a 9 here. 15. This has to be a 5 because of the 20 on the other side. So for that, let me just do that here. I'm going to have 16 plus 27 times 5 divided by 2. And when I do that math, I get a 107.5. So I'm going to subtract that. So 783 minus 162 minus 107.5. I get a 513.5. On number 6, I want to decide if this triangle is possible. I know all the angles have to add to 180, so I'm going to take 2x plus 110 plus 2x plus 90 plus x plus 5, set it equal to 180. So that's going to be a 5x plus 205 equals 180. I'm going to subtract 205. And I get a negative 25. I divide and I get a negative 12.5. Now, it's okay to have a negative x, I just can't have negative angles. So what's going to happen is when I put this in here, that's going to become negative. So this is not going to be possible. It's going to give me negative angle. Not possible, negative angle. So not a triangle because the angle will be negative. The other two will not be, but this one will be negative, and that's enough. Number 7, write a converse statement for each of the following. Assuming the original statement is true, determine if the converse statement must be true, explain your reasoning. So if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse, okay? So they're really saying a squared plus b squared equals c squared. So we're going to say the converse, which is if the sum of the squares of the lengths of the legs is equal to the squares of the length of the hypotenuse. Then the triangle is a right triangle. And that is true. So anytime you are doing like 3 squared plus 4 squared equals 5 squared, which is true, that means you have a right triangle. That is going to be a true statement. On B, if a polygon is a square, then it is a rectangle, okay, because squares are rectangles. Now we need to write the converse. So if a polygon is a rectangle, then it is a square. And that is false. And just as an example, if I get a rectangle here and I draw it out, that is a rectangle. Let's say that this is 3 by 5. That is not a square. On 8, are the triangles similar? Justify your conclusion. So looking at this, I have this angle with this angle. Okay, so angle T and angle A are congruent. I have angle S and I have angle E, so they are congruent. And that's enough. That's going to be angle. Okay, so right now I have angle similarity. So yes, they are similar. Sorry, I think I said congruent. On B, determine the perimeter of the triangle TES. So perimeter of TES is going to be 3 plus 10 plus 11. So we get 13 plus 11 or 24. Now it says using a proportion, show how you can calculate the perimeter of triangle ANE without determining each of the sides. So at this point, if I know that these are similar, okay, which I do, and I know that this 3 corresponds with this 12, what I'm going to use that ratio. So what I'm going to do is I'm going to go 3 is to 12 as my perimeter 24 is to my bigger perimeter. Okay. So I'm comparing the smaller side with the bigger side, the smaller perimeter with the bigger perimeter. And they should be proportional. And then I'm going to cross multiply and solve, and I get 3p is equal to 12 times 24, which is 288. I divide by 3, and I get 96. Okay, they wanted us to separate proportions, so that's what they wanted us to do. Now, what you can also notice is that what am I doing from 3 to get to 4? Well, I am timesing by 4 to go this direction, okay? Or if I'm going the other direction, I am timesing by 1/4, okay, depending on which direction I'm going. So I want to go from the smaller to the bigger. So here I was timesing by 4. So if I take this perimeter and I times it by 4, I also get that same 96. But they wanted proportions. On 9, I'm going to dilate this with a scale factor of 3 from the origin. So this is where I'm going. So what I'm going to do is I'm going up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And that is going to get me to this, which is going to be M prime. So I'm just doing that slope 3 times. How am I getting from the origin to N? I'm going up 2 over 1, 2, 3. So I'm going to go up 2 over 1, 2, 3, and up 2 over 1, 2, 3. And this is going to be n prime. For O, I'm going down 2 over 2, down 2 over 2, down 2 over 2. And that is O prime. And then going to P, I went over 1. So I'm going to go over 1, 2, 3. And so this right here is going to be P prime. And then I can connect and get my new, let me get my line tool. So I'm going to connect those, these, and there you go. On 10, I need to find the outside of this one. So this is going to be an X and an X. This is going to be a +3 and a -5. And they want us to write air as a product. So X plus 3 times X minus 5 equals area as a sum, which is the inside. And that's going to be X squared minus 2X minus 15. For the second one, this is going to be a 2X squared. This is going to be a negative 6X. This is going to be an X. This is going to be a negative 3. So this is going to be 2X plus 1 times X minus 3. That's your area as a product equals 2X squared minus 5X minus 3. That's your area as a sum. On 11, so I know that this M to P is going to be the same as this one because they have the same tick marks. I know that this purple one here is going to be the same as this purple one here because they have the same. And they also share this one that's in the middle, okay, because of reflexive. So I'm going to say that this is by side, side, side congruence. And M is going to go with O. And N is going to go with N and P with P. On 11B, this side they're going to share. When I have these parallel lines, so let me just draw these purple parallel lines, cut by that blue transversal, this angle here and this angle here are going to be the same, okay, because of alternate interior angles. I also have this orange parallel line with this orange parallel line, and they're going to also give me alternate interior angles, those ones. And so when I'm looking at this, I'm going to have angle, side, angle. So angle, side, angle. And I have to be careful because if I'm looking at this triangle here that I'm doing in pink, and then this one that I'm doing in teal, KLN is my pink one. And what you want to be careful of is K, it has the orange one, and N has the orange one. So that's going to go with N. L is going to go with M. And then my N, which was this purple one, is going to go with this K, which is my purple one. On 12, determine if a triangle whose sides lengths can be made or not. And if so, determine if the triangle is a right triangle, justify. So what I want to do first is, let's just say I take this 26. Is that acceptable? So I'm going to take 10 and 24 and add them and get a 34. I'm going to subtract them and I'm going to get a 14. And 26 is in between those. So 14 less than 26 less than 34. So yes, triangle. Then if it is a triangle, they want us to see if it's a right triangle. So now I'm going to be looking at right triangle. So I'm going to go leg squared plus leg squared equals hypotenuse squared. Hypotenuse is always the bigger side. And so when I work that out, let's see, 10 squared plus 24 squared is 676. When I do 26 squared, I get 676. So it is, yes, it is a right triangle. On the next one, let's say I try to get that 33. So I'm going to do 13 plus 20 is 33. I'm going to stop right now because I can't have it be 33. They can't equal, it has to be in between. Okay, has to be less than 33. So this is not a triangle. And then you don't even have to try for right. On 13, can we make this? So looking at this, this is going to be a 50 degrees. Okay, that's acceptable. That's because of triangle angle sum. Triangle angle sum. Now, is that reasonable? So what I want to look at is the biggest side should be across from the biggest angle. Okay, and that is so. And the smallest side should be across from the smallest angle, and that is not. So, fails, well, I should say, not a triangle. Because the smallest side, which in this case is 15, needs to be across from the smallest angle. And in this case, that should have been the 30. And that's the end of this video.